Good day, sir. Also, good day to my fellow presenter. So today we will present our data analysis and interpretation of MAC data as part of our performance innovative task for engineering data analysis. So the presenter for this task is Jericho Ceniza, me, Zandara Pacham, and BillAlexis Majala, and Mariz and Semine. So the scenario in this task is that a civil engineer is tasked with evaluating the failure probability of a building's structural components. It includes the beams and columns over 2 years. Earthquakes, materials fatigue, or extreme wind loads could cause the failure of the structure. The engineer uses historical data to model the probability failure using both union of probabilities, overall failure and probability, and binomial distribution and consider each function independently.
So these are the steps we did in generating, calculating, and interpreting historical data. Step 1 is we generate the data from external source, which is Mokaro. Step 2, we make base for high and low data. Then after that, we calculate the probability of each factor, which includes the overall probability rate of environmental conditions, of traffic load, and of material fatigue, where our variable is the high value. Then the overall probability of failure using a formula given by this task. Next is we calculate the binomial distribution per month, then we create the graph to better understand the relationship between data. This is the 2-year historical data laid out in Excel. The high value of each variable represents the data that is above the constants.
From that 2-year historical data, under environmental conditions, the failure probability is 49.5%. If engineer will base this data for the next 2 years, there is a 49.5% chance that a failure will occur in next 2 years due to temperature. The failure probability for traffic load is 34.5%. If load exceed 46,000 tons, so if in next 2 years, 34.5% chance that failure will occur due to traffic load. Now, in the last factor, for evaluating failure probability of building structural component, material fatigue has an overall probability failure rate of 27.5%. Now, given that the failure probability rate of environmental conditions, traffic load, and material fatigue over the span of 2 years is 49.5%, 34.5%, and 27.5% respectively. Using the formula for union of probabilities, the overall probability failure is 76.2%. So what does this mean? This means that by using this historical data, there is a 76.2% probability that a high failure rate will occur over the next 2 years. If we are going to base our prediction from this historical data, this data is important for a civil engineer so that they can make an action over the structural component of the building and so that the probability rate of failure will be reduced or else catastrophic event will occur and could alter people's lives.
Let's discuss the probability failure and the binomial distribution per month of the following 3 factors. Now, for environmental conditions, these are all the datas in ordered months. We can see from the 4th and 6th column the probability failure per month and the binomial distribution per month. Let's understand their relationship through tables and graphs. So from the graph, the highest probability that failure will occur with temperature as its factor is on 2023-04 or April 2023, having a 100% failure rate at the low, and the lowest rate is in 2022-08 or August, and 2022 of December, having percent close to zero. Now, if we look at the binomial distribution graph, it is already 2022 of August and 2022 of December who has the highest percentage, where 2023-04 now having 0%. So what does this means? This means that the probability failure and the binomial distribution are inversely proportional, where the probability failure per month shows the month with highest probability a failure will occur, and the binomial distribution will show the month with highest probability a failure will not occur. Now, our analysis from this data is that the month with highest probability that a failure will occur over the next 2 years under temperature is on month of April, and the month with the lowest probability that a failure will occur is either on August or December of the year. This is based on the binomial distribution graph. Now, for the traffic load, same calculations is applied just like environmental conditions data to get the probability failure and the binomial distribution. Now, from the graph, the probability failure per month, the month with highest probability of failure rate due to traffic load is on 2023 of January. Now, based on the binomial distribution graph, the highest percentage is on the month of August 2023. But since it's inversely proportional to probability failure rate graph, this means that August 2023 in binomial distribution shows the highest chance that failure will not occur. Now, in conclusion, the civil engineers could predict that in 2 years, the month who has the highest probability of failure is on January of coming year, and potentially August will be the month that has the lowest probability rate of failure. Now, these data are under the sa material fatigue. Now, based on the graph of probability failure per month, the month who has the highest probability failure is on February 2022. Now, on the next graph, now based on graph of binomial distribution, the month of September 2022 and the month of April 2023 has the highest rating. This means that these months have the highest chance of failure not occurring under the material fatigue. Now, for the next slide, in conclusion, under material fatigue, in the next 2 years, the highest probability failure is on February, and the lowest probability of failure is on September and April in those years. Now, for the overall analysis for the next 2 years, without proper mitigation and action towards structural components of the building, the civil engineer will expect a probability failure of equal or greater than 76.02%, which is the overall probability of failure under three considered factors. So this ends our presentation on the data analysis and evaluation of a 2-year historical data